Hello, thanks for tuning in. If you are watching, today is November 30th or December 1st, depending on what day you have math. We are going to be in one of your stapled packets from the iReady book. Look for page 92 to 93. It should say Lesson 10, Guided Practice, and the top part should say Connect. We're going to continue identifying proportional relationships. And this page has 3 graphs right at the top, so it might be kind of easy to find. All right, so today we're going to kind of continue our conversation about what a proportional relationship looks like in a table, in an equation, and in a graph. So let's dive right into question 12. It says compare. The graphs below show the number of points you earn in each level of a game. So we have game A, game B, game C. The x-axis is our level. The y-axis is our number of points. Which games, if any, have a proportional relationship between the number of points you earn and the level of the game? Okay, that's our first question. So we have to remember when we look back and think about what we've done, what graphs are proportional. So remember, they had some very specific criteria. They have to be a straight line, and they also have to go through, do you remember what point? If you said the origin or 0.00, you are correct. So if I look at game A, it's a straight line. And does it go through the origin? Yes, it does. So game A is proportional. Put a little star here. Game B, it's straight, but does it go through the origin? In this case, game B does not. So game B it's a great line. It represents a function. It's just not proportional. Game C, is it a straight line? Yes. Does it go through the origin? Yes. Okay, so for question 1, we're going to say games A and C are proportional because they are straight lines and go through the origin. Okay. Next question says, in which game can you earn the most points in level 2? So, level 2. So let's look at game A, level 2. So I'm going to come over. The level is on the x-axis. I'm going over to level 2. This is a 100. So this is 2, 100. So the 100 is the number that we're looking at. If I go to game B, I'm going to come over, level 2, and I'm going to go up 150. Okay, again, I'm looking at that y coordinate. Next, I'm going to go over level 2. I'm going to go up 200. So the question says, in which game can you earn the most points in level 2? So these are all level 2 because they'll have x coordinate of 2. 100, 150, 200. What's the highest? It's going to be 200. So game C, in game C, you can earn the most points. You could even be thinking about like what's the COP as well when you look at a graph. Remember, if you go over 1 and up however much that is, that's your unit rate. So this unit rate is 1, 50 because it's proportional. And this unit rate is over 1, 100. So this unit rate is more points anyways per level. So you know right away it's going to be game C. So some of you might have looked to see, the unit rate's higher anyways. All right, so that's question number 12. So we talked about what graphs are proportional, what ones aren't, and why. Number 13. It says apply. Servers at a snack shop use the table below to find the total cost for frozen yogurt, but some of the numbers have worn off. The total cost is proportional. So that means we know all the ratios will reduce to the same number, to the number of cups of frozen yogurt. So the total cost is proportional to the total number of cups of yogurt. So that means that when we take one piece of information, we should be able to find the unit rate, and then that should be able to help us fill in the rest of our table. So I know that if I buy 4 cups of frozen yogurt, it's going to cost $18. So that's a rate, right? I'm going to move my arrow out of the way for you. Sorry. That's a rate. We learned that we could take this rate and we could make a unit rate, right? A unit means per 1 cup. So I'm going to take my $18 and I'm going to divide it by 4. If you're plugging it into your calculator, it would look like this, 18 divided by 4. So let's plug in 18 divided by 4. So 4.5, since we're talking about money, that means that 1 cup costs $4.50. From here, let's see, find the missing numbers in the table. Okay, so we found the unit rate so far. And now they're asking to fill in the rest of the table. So if I know 1 cup costs $4.50 and it's proportional, I know I can find 2 cups by taking this number and doing what with it, do you think? If you said multiplying by 2, that's correct. I'm multiplying by 2. So $4.50 times 2. Now, I know what it is, but if you're not sure, you can hit times by 2 on your calculator. It'll tell you it's $9. All right, now I'm going to triple that. So now I have 3 cups. So I'm multiplying by 3. So I'm going to do $4.50 times 3. That's right. So 4.50 times 3. Notice I left off the 0 here. It doesn't change the answer. So if you want to leave that off, that's fine. And that's going to be 13.50. All right, so let's go back and make sure we did everything. The total cost is proportional to the number of cups. Find the missing numbers. We did that. Check. These questions are pretty easy, aren't they? 14, analyze. Michael says that the difference between Danny and Raj's age is always the same. So Raj's age is proportional to Danny's age. Is Michael correct? Okay, so he's saying 2 things. He's saying the difference between them is always the same. So difference means to subtract. So he's saying if you subtract these, you always get the same number. Well, 10 minus 5 is 5. 15 minus 10 is 5. 5, yep. Okay, so I agree with the first part, check. But he's also saying it's proportional, which means all these ratios in the table should reduce to the same thing. And we could also do the cross products to make sure they're equal. I'm going to take and just write a ratio and see if we can reduce it. So it's the ratio of Raj's age is proportional to Danny. So because they said Raj first, they want us to have that number on top. So it's going to look like this, 15 over 10, 20 over 15, and 25 over 20. Okay. Well, I can tell right away this first one is equivalent to 2 over 1. And if you don't believe me, you can always take your calculator and plug in 10 ABC5. It'll reduce to 2. So that's 2 over 1. If I reduce 15 over 10, well, that gives me 1.5. 1.5 is the same as 3 over 2. Are these 2 ratios the same? No. And you know what? I don't need to go any further. We just proved that it's not proportional. So is Michael correct? We're going to say no. Mike isn't correct. The ratios are not equivalent. And there we go. That's that. So yes, the differences are the same, but the ratios are not equivalent. All right, we're going to look at the next page, which is page 93. I added a couple things just to save time on the video a little bit. So this is called putting it together. Use what you know to complete this task. So it says Paige works in an art store that sells square pieces of canvas. There are 5 different squares to choose from. So canvas A is a length of 1 foot, B is 2 feet, and so on and so forth. So you notice they're just nice consecutive, even whole number answers, right? Okay. Shouldn't say even. They have even and odd there. They're whole number answers. Part A says make a table to show the perimeter for each square piece of canvas. Use the formula P equals 4S. Okay, so our first task is to make a table. Before I read any more, I'm just going to do that for right now. So if the side length is 0, the perimeter is 0. If the side length is 1, well, I'm going to put in perimeter equals 4 times my side length is 1. 4 times 1 is 4. What if my side length is 2? Perimeter equals 4 times 2. 4 times 2 will be 8. What if my side length is 3? Perimeter equals 4 times the side length, which is 3. 4 times 3 is 12. So how about for 4? Perimeter equals 4 times 4, which is 16. So if at any point you need to pause this video to kind of catch up to where I am, you're welcome to do so. If the side length is 5, perimeter equals 4 times 5. That's going to give me 20. All right, we made a table. We used the formula. Check and check. Then draw a graph to compare the length of each side to its perimeter. Use the graph and table to explain whether it's proportional. All right, so I went ahead and I made just a quick little graph. My side length is my x axis. My perimeter is my y because my side length affects my perimeter. So in this case, my side length, I'm just going to increase by ones. My scale, I'm going to go by ones. And my perimeter, I'm going to just use the numbers here because I'm increasing by 4, so I can make a scale of 4. So it's 4, 8, 12, 16, and 20. All right, so my first point is 0, 0. That's on there. 1, 4. So I'm going to go over 1 and up 4. 2, 8. I'm going to go over 2 and up 8. 3, 12. Over 3, up 12. 4, 16. Over 4, up 16. 5, 20. Over 5, up 20. Now, you may be saying, Mrs. Krell, that dot's a little off. Yep. Remember, I'm not using like actual graph paper here. So my line, if I use graph paper, would be nice and straight and it would go through the origin. I could actually adjust that 5 and 20 and move that point over. So my line is straight, okay? If I'd use graph paper to be even better, more professional. So it says, use your table and graph to explain whether it's proportional. Okay, I could have told you it was proportional based just on the table. The table has a COP. What are we multiplying by each time my x to get my y? 1 times what gives me 4? 1 times 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. So because my COP is 4, based on the table, I can tell you it's proportional, which means that the graph should be straight, barring any human error, and go through the origin. Okay, so we did all the tasks up here. We made a table, we used our graph, had a little bit of human error to tell that yes, it was proportional. So we're going to say yes, it is proportional. All right, let's take a look at part B. So part B says make a table to show the area for each square for the piece of canvas. And it says use the equation area equals side length squared. So a little exponent here. So I'm going to start with 0, 0. And I'm going to bring down my numbers 1, 2, 3, 4, and 5. Remember, we had just consecutive whole numbers here. So 1 squared, so 1 times itself. 1 times 1 is 1. 2 squared. Well, 2 times 2 is, so this written out is 2 times 2. That's 4. 3 is our side length. That's going to be 3 times 3. That's going to give me 9. Area equals 4 squared. 4 times 4 is 16. What's our last one going to be, do you think? If you said 5 times 5 to give you 25, that's correct. Okay, so we made a table. We used our formula. Then draw the graph. So 0, 0, 1. Okay, I got to make my scale first, right? So my scale is 2, 3, 4, 5. And then I don't really have a scale that's going on here. And if I go by 4s, I'm going to miss a couple of these, but it's close. So we'll do 4, 8, 12, 16, 20. All right, 1, 1. Well, I got to break this up. 1, 1 is here. 2, 4, over 2 and up 4. There's that. 3, 9, over 3 and up 9 is a little above the 8. 4, 16. Oh boy, are you guys seeing what I'm seeing? This is not human error. This is definitely not going to be a straight line. 5, 25 would be up over 5, up past the 24 to the 25. It makes a curve. Okay. This is actually a very specific type of function you'll learn about in 8th grade. It's not proportional though. So our graph is not straight. And it does go through the origin, but in this case, the fact that it's not straight proves that it is not proportional. And our table does not have a COP. Here it looks like we're multiplying by 1, then by 2, then by 3, then by 4. So there's nothing that's a constant rate of change. So in this case, there is no COP. All right, so today's lesson, we reiterated the idea that we can take a table and find a COP. We're looking at graphs to see if they are straight and go through the origin. We reviewed going from a rate to a unit rate. And then we also looked for equivalent ratios. All right, so I hope you found this video helpful. You are going to have a little bit of practice in your blue packet. So that's the next part you should be jumping to. The practice you're going to do is out of your blue packet.